For 11.1 notes, this is area of a parallelogram and perimeter and area of triangles. So at the very top, I did include formulas for square and rectangle because you will be using those throughout for something called composite figures. But currently we need to use the parallelogram formula, area equals base times height. So when you're looking at this picture here, this is your height. So it's the perpendicular distance from the vertex to the other side, and it creates a right angle. Okay, so this is your height. Your base would be where that height ends. So it starts here at the vertex, but it ends down here at the bottom. That's your base, which means that this right here is extra information that we don't need. So area equals base times height. So 5 times 4 is 20 inches squared. Area, you always put a little 2 there for squared. So for part B, we have our height. Our base would be 2, and that would be extra info. So base times height, 7 centimeters squared. Okay, for a triangle, we want you to find area and perimeter. So I'm going to start with perimeter first. I think it's just easier to do. So perimeter, you're adding all your sides. Okay. So we'd have 5.8 plus the 6, and then 2 plus 5 is 7. So if I add those up, our perimeter would be 18.8 meters. Now for the formula, area equals 1/2 base times height. We're looking at, I'm going to go with the height first. So the height has to go from the vertex to the opposite side. Okay, that distance there. So that would be 4. And then your base would be 7, since it reaches here. So 7 times 4 is 28. And then half of 28 is 24 meters squared. In letter C, when it is a right triangle, it's a little bit trickier. Okay, because your height is actually one of the legs. So if I say this is my height, it would go to this as your base. Okay, so let's do perimeter first. For perimeter, we would add all the sides. And let's see if the light makes any difference here. Okay. Then if I add those, I get 40.2 yards. Then for the area, okay, we said our height was 6.7, where the base would be 15. So I normally would multiply those together and then divide it by 2, taking half. So if I multiply those together, we get 100.5. Taking half of that, but it does say round to the nearest whole number. So let's divide real quick. 100.5 divided by 2. So 50.25, but we have to round to the nearest whole number. So that would just be 50. So this said 50.25, but we're rounding, so 50 yards squared. So nearest whole number is right there. Okay. For this part, I highly recommend using that Google Calendar. So going to Google, type in calculator, first thing that pops up. I have a picture of it on the page under resources for this lesson 11.1, because we do have to use sine. You can see that is in the formula. Okay, so let's go ahead and break this down. So the B and the C in the formula here are the sides that are going to be next to each other that have the angle in the middle. We call that the included angle. Okay, so it doesn't really matter which one is B or C. but B and C where the included angle is in between them. So to set up the formula, we would have area is 1/2 12 times 21 times sine of 48. So I would personally multiply all of this first. I would multiply this, divide it by 2, and get that number. Okay. Now you guys can do that on your calculator. So I'm going to do 12 times 21. That gives me 252. Okay, if I take half of that, I get 126. And then sine of 48. So basically, before I do the times sine 58 or 48, I'm going to make sure that I'm in degrees. Now on the calculator on Google, same thing, you have to press the degree button in order for it to come out correctly. So I did the 126 times sine 48, and it does say round your answer to the nearest thousandth. So we're going 636, and so that 2 makes the 6 stay where it's at. Okay, so let's say we have 93.6362. 2 makes the 6 stay. Alright, so the next one, let's set it up. So we see that the two sides have the angle in between them. So 1/2 times B times your C times sine of the angle. Okay, so 10 times 16 would be 160. And then half of 160 would be 80. And then we can do 80 times sine of 34, and we would get 44.7354. So that 5 is in the thousands place, that 4 keeps it there, and that would be inches squared. Okay, now composite figures. There's a few names for them. So you can call it a regular figure, composite figure. It's basically when you take 2 or more shapes and you put them together to create something. So obviously here we have a triangle and a square. You could have a rectangle and a triangle, or a rectangle and a square. All kinds of different combinations. So I'm going to go ahead and break it down. So the first thing I'm going to find is my square. Okay, square is area equals side squared. Well, in a square, all the sides are 6. So 6 squared is 36. 2, I'm going to find the area of the triangle. So I've got the base being 6 here, okay, the height being 8. So I would say 6 times 8 and then half that. So that would be 24. Okay, and then lastly, the area of the composite figure would just be what you get when you add up 36 and 24. So I would get 60 inches